So, I think it's not surprising that today's topic is mythical or mythological application monitoring that I've been doing today as a VMPL employee. I'm really happy to get this opportunity to do it. I'm gonna share with you my thoughts, my recent experiences, and we're also really thankful for our recent collaboration with BestHex. We did some great things together. We've done some great things together. It was one of those hackathons on technical University of Technology in Wrocław. So yeah, I'm really happy to be able to continue that trend and to share this presentation with you today. So briefly about me, I'm Tomasz Kluza, to be more specific. I'm full stack developer at VMPL. I've been here for almost over 2 years now. I'm really happy to be able to speak about those topics, and without VMPL it wouldn't be possible. So you can contact me via mail or maybe via GitHub. Today I'm gonna present you some kind of test project that I base whole presentation on, and it's available on that GitHub. If you want to have a look, just go to that GitHub, and the all projects or services are there. This picture is about me. It describes me as a person, as a hobbyist. I really like to travel a lot, and I'm also some kind of shopaholic. But I think it's not that good. But yeah, I'm open to talk about it. So I think that's good already. And I'm big fan of USA, and I fell in love in New York. That's why this picture says a lot about me. But yeah, that's about it. What we learn today. I think it's not gonna surprise, or maybe a little bit. It's gonna be a mythology lesson. So who was the mythological Prometheus? Maybe not this time. We're gonna skip that, so it's maybe another presentation, maybe another day. Let me know. But today we're gonna focus on what is the monitoring and what is the application monitoring, to be more specific, and what's different types we can distinguish. We also gonna concentrate on why we need it. So if it's emergency technology or like convenient, there are plenty of advantages, but we must understand why. So next we're gonna make deep dive into APM, which stands for Application Performance Monitoring, which is one of those types, which, in my perspective, gathers the most information. Then it's gonna be game time. So we're gonna start with the Prometheus, but this time it's not gonna be that mythological one. Then I'm gonna explore and show you the smart city. The smart city was the idea about this as a main topic of that hackathon that we did with BestHex. So I thought I'm gonna explore it a little bit further and give it a try. It's gonna be very, very simple application about autonomous car reservation. But the business logic itself is really simple, but it's not about the business logic. We're gonna watch what happens inside our containers, our applications. Then we're gonna see it in action. We're gonna generate some dashboards in Grafana. You're gonna see how fast you can get some very rich dashboard that's available in Grafana based on already existing one from Grafana Labs. And yeah, I think you're gonna like it. Monitoring is today at the end of this presentation. Monitoring is gonna be everywhere. So yeah, what stands behind the application monitoring actually? So we can say that it's a regular observation and recording of activities taking place in a project or program. It is a process of routinely gathering information on all aspects of the projects. But application monitoring, nevertheless, is a broad, wide topic, which is better understood when it's broken down into some various components. And in the following slides, I'm gonna share and explore those different components with you. So yeah, what are different types of monitoring that we can distinguish? So let's start with availability. Let's start with availability, and it's like it refers to, it's like the most mature type of IT monitoring. It includes categories such as server management, infrastructure monitoring, management of and network monitoring. This is designed to provide user with information about uptime and the performance of whatever is being monitored. Then we have some API monitoring, which some enterprises that offers APIs to third-party developers and companies. We find it crucial to ensure that the uptime of the services. API monitoring tools are software provides insight into whatever an API is working properly, ensuring minimal downtime. Then we have something that's gonna be almost there. It's like what performance monitoring, and it's like subset of availability monitoring, and it's designed to monitor the availability of web server or service, but also adds more fine-grained detail to the system. These tools can capture information such as page loading time, the location of errors that are generated, and the individual load times of various web elements, helping analysis to fine-tune a website or a web-based app's performance. Then we have something that we're gonna dive into a little bit later. So it's APM, stands for Application Performance Monitoring, as I said earlier, and it's quite similar to web performance, but they designed so with a customer-facing application in mind, allowing analysts to track the performance of an application and spot any issues before they come to severe for the user base. Modern APM tools can include automated routines to troubleshoot these issues without the intervention of a human developer, which is very helpful. Then we have also real user monitoring designed to record actual end user interaction with a website or application. By monitoring real world load times and user behavior, it can be pinpoint problems based on real user experience challenges and not to some kind of simulation or tests. We have also security is designed to observe the network for breaches or other unusual activity. Is a broad high-level category that includes numerous subsets of security analysis tools. And last but not least, we have also some kind of business activity monitoring, which stands for BAM. This type of monitoring takes key business performance metric and tracks them over time. For example, these metrics could include information about retail sales, application downloads, or the volume of financial transfers. So, as I mentioned earlier, we're going to explore APM a little bit deeper. So, APM is one of the key components is the automatic discovery and mapping of the application and its infrastructure components to maintain real-time awareness in dynamic environments. It's also end-to-end observability of an application complete via HTTPS transaction behavior to understand the effect on a business and user experience. We also have mobile and desktop application monitoring on mobile and desktop browser to track user experience across platforms. We have root cause and impact analysis of application performance and business outcomes for much faster, more reliable incident resolution. We have also business KPIs and user journeys analysis, for example, login to checkout, which is very popular in e-commerce world, to optimize user experiences and provide transparency into how changes impact those KPIs. Then, as I mentioned earlier, we have also API monitoring to understand how application performance is impacted by third-party services. We can also monitor the application architecture to gain insight into how different changes to the architecture impact the performance and user experience. And then last here, we have a service and containers monitoring to understand how individual services and containers interact with each other and how they impact the overall application performance, on system performance. Okay, so I think so far we get some insights, key features of the monitoring and APM, to be more specific, but I think it's not enough. So to understand the tool, understand these capabilities, we need to understand why we're gonna need it. So today I'm gonna start with that Simon Sinek quote that people don't buy what you do, they buy why you do it. So now we're gonna concentrate on that. We're gonna explore it a little bit wider, deeper. Why do we need APM? So for sure, we have some technical benefits, and one of those are increased application stability and uptime, a reduced number of performance incidents, faster resolution and performance problems, faster and high quality software releases, and improved infrastructure utilization. But on the other hand, we have also business benefits, which might be really convincing for being able to convince our clients to integrate with them. And we have improved developer and operation productivity. We have increased time spent on innovation, increased revenue, reduced operational costs, increasing conversion rates. There's like plenty big advantages here. And as I mentioned, as I'm gonna show you, there are not many downsides or maybe disadvantages, because to be able to deploy it and understand it's gonna take just a little bit of learning curve, but it's not that far away and it's not that difficult. So I think personally, I'm convinced I can explore this idea a little bit further. If I wouldn't, I would stop right here and we would say goodbye. But no, it's time for main agent of today's presentation. It's Prometheus, and I think it's not surprising. That was then stood behind that mythological name. And Prometheus is with us some time, and it's like open source systems monitoring and alerting. Originally built in 2012 on SoundCloud. It collects and stores its metrics as a time series data. Metrics information is stored with a timestamp at which it was recorded, alongside with some optional key value pairs called labels. Those are like key components of Prometheus, metrics and labels. So let's explore main features. Then we can get from Prometheus what Prometheus offers. It stores our metrics in time series as a time series in multi-dimensional data model, which where the data time series is identified by the metric name and key value pairs. We have also PromQL as a flexible query language to leverage this dimensionality. We have no reliance on distributed storage. Single servers nodes are autonomous. Time series collection happens via pool model over HTTP, so it's like really flexible, and every client can integrate with it. We can also pushing some time series into supported. It's also supported via intermediary gateway, so we don't have to share HTTP client, HTTP endpoint with Prometheus. We can just push some metrics to the Prometheus directly via that push gateway. And we have also multiple modes of graphing and dashboarding, which Grafana complements just flawlessly. So yeah, as I mentioned, metrics and labels are like key components of Prometheus, and as I already mentioned, every time series is uniquely identified by its metric name and optional key value pairs called labels. And the metric name specifies a general feature of system that is measured. For example, HTTP request total, this stands for like total numbers of HTTP requests received. It might contain letters and digits as well as underscores and colons. We have also labels, which enable Prometheus dimensional data model, and a given combination of labels for the same metric name identifies a particular dimension instantiation of that metric. So for example, when we say about the HTTP request that used the post method on given API handler endpoint, for example. So that's the label. The query language allows filtering and aggregation based on these metrics, based on these dimensions, and changing any label value, including adding or removing a label, will create a new time series, which is very important information. We must just have that in mind, that when we want to put many new labels and many labels, we have to keep that in mind, that our complexity, that's the data that's gonna, those time series that's gonna be stored in the database are gonna increase. And that's why we have to take care of just put those labels which are crucial for our system. Labels might also contain some letters, numbers, as well as underscore. So that's the example of the HTTP request metric that I mentioned. It's with two labels. The first one is method, the other is handler, which could be API, for example. And we can see it's like we see some kind of also PromQL here. So we have some metric, and we can, like, as I said, some kind of group by condition from SQL to gather information for those specific labels. Okay, then we can move a little bit further, one step further actually, and we're gonna distinguish different metrics and different types of metrics than we have in Prometheus. So the first one is counter, and the counter is a metric value which can only increase or reset. The value cannot reduce then to the previous value. It can be used for metrics like number of requests, of errors, numbers of activities. Then we have gauges, and gauge is a number which can go either up or down. It can be used for metrics like number of pods in a cluster, number of events in a queue, or maybe number of active users that's using our application. We have also histogram, which is more complex type when compared to previous two. Histogram can be used for any calculated value, which is counted based on buckets values. Buckets boundaries can be configured by the developer. A common example would be the time it takes to reply to a request called latency. Last but not least, here we have summary. And summaries measure events and are alternative to histogram. They are cheaper but lose more data. They are calculated on application level, hence to aggregation of metrics from multiple instances of the same process is not possible. So there is also recommendation from Prometheus side to use this, highly recommended to use histogram over summaries wherever it's possible, just to not to lose the data and to not be tightly coupled with our clients. So okay, I think so far so good. I will say I'm gonna take some water. I'm gonna explore with you some smart city idea that I built in the recent days. But as I mentioned, it's gonna be really simplified. So that's the data class diagram that I built. I'm gonna move my cursor into it. So we have two applications, two services. So we have a smart mobility application, which contains information about reservation of autonomous car and information about users. Those colors are not that are like some role behind it, some logic behind it. I'm big fan of strategic DDD. So those are like different, let's say, domains in our application. We're gonna see it in the moment. And as I said, in this application, our main domain calls reservation, and it's connected, but not directly on the database layer, but on the business on the service layer via business key with our payment. And that's our second application, which calls payment application. There we have we're gonna process some payments from those specific reservation. This is very simple use case here. We're gonna just mock those behaviors. We're gonna say on some application YAML settings, that what's the percentages of the confirmed payments and of the declined payments or rejected payments, just to show, just to explore some kind of real world behavior. But as I said, it's just simply just quite simple in its nature, but we're gonna see how powerful monitoring those two applications can be and what we can receive. We can also hear some kind of C4 diagramming diagram, and this one is called, it's like that second layer is container diagram, container level. So we don't have any UI right now. I didn't build any UI for our application, but that would be a goal, to be able to provide those APIs to our user via mobile or front-end application. Those services have two separate databases. Both are H2 right now, just to make sure that the whole solution is quickly up and running, but we are flexible here. Both applications are Spring Boot applications with newest stable version, but with small spontaneous difference here. One of them is written in Java, and that's the smart mobility app. And the another one is written in Kotlin, because Springs work really well with Kotlin, and I'm a big fan of Kotlin as well. So that's the idea I'm gonna show you today. And here we can see some that Prometheus and Grafana monitoring just gonna scrape those metrics from our system for both our APIs from specific endpoint. Then I'm gonna show you how to configure. So yeah, it's good time to be able to start our coding session. We are in IntelliJ. As I mentioned today, we don't see any UI, because that's not the main topic. But I can provide that. That was one of my goals, to provide UI in the next steps, so to say. As I said, it's Spring Boot application. I'm gonna just, I hope I just zoomed in, I changed the font a little bit. I hope it's gonna be more visible for you guys. And I'm not using it normally. I'm not that blind, I would say, with all due respect. And yeah, we have some POM parent, and we have definition of two services, two applications. Both of them are in Spring, as I mentioned. And let's dive into a little bit to the architecture. Both are built in kind of same way. I follow some kind of hexagonal architecture pattern principle here. I've built some business package, and in business we have all different domains of our application from strategic DDD definition perspective. And I have some reservation domain which has some API, which has some configuration, which has domain definition, which is quite nicely extracted from all the another framework details. Those are quite simple modules, so to say. And we have some DTOs, and as you can see, we have some commands, we have some events. So it smells like some kind of event system. It doesn't use any async provider in terms of Kafka or Rabbit, but I just programmed it just that way that those different domains just publish some events. And those events are gonna be catched by the it's gonna be published by application event publisher from Spring. I can show you right now. And those events gonna be like for another, let's to say, another step in our process. So as for example, I have some payment confirmation event. So when the specific payment has been confirmed, I just catch it on when the transaction is being committed, just to make sure, okay, I'm not gonna talk to another external system when my transaction is falling apart. So in that way, I'm just making sure, okay, when it's really has been saved or updated or deleted, I'm gonna send those specific requests. So that's some kind of event-driven, but the next step would be just to build some integration with Rabbit or Kafka and push those events, those events not via HTTP client, but to capture them via message listeners, for example. So yeah, those are like different, let's say, the project structure. I'm gonna show you something very quick. Also, as I said, the reservation is our main domain here. So we have some facade. We can create reservation for load test purposes. I've built also some kind of random reservation, which is gonna like create some reservation based on our data, but randomly. And we can also confirm and cancel the reservation. Those endpoints gonna be reached by payment system, payment application when the specific payments has been processed. Yeah, I think that's about it. I'm gonna launch them very quickly just to show you that it's working. I hope it works well. I've tried, but we have presentations, so anything can happen. Okay, the first one is started. The another one also. I'm gonna just remove all the logs to make it a little bit clearer what stands behind it. I made some kind of endpoints, so HTTP endpoints, just to provide you with some proper examples. Those are all it's accessible, available in repository under the scripts. So yeah, I'm gonna reach the first endpoint. It's gonna be smart mobility reservation, and I'm gonna just share the first reservation with you guys. It's been processing. We don't see any. Okay, the payment has been confirmed, and we're waiting for the confirmation. Great. So that was some kind of like async logic, so to say, with some kind of delay. Let's put it once again. We have also some kind of business logic that specific user can have two open reservation, and a specific car can be added to 4 reservations as well. Sometimes we can have some kind of business exceptions as well, and we're gonna track them in our monitoring. We're waiting. So as I said, specific user can have 2 reservation. I've made already, that's the second one. Now I expect it for 100, and it's like but request. I didn't provide any specific handler here. I just based that on the client 400 exception, which is bad request, and that's it. But of course, you can put it some more fine-grained error handling as well. So yeah, that's the application. Of course, under both of them stays the H2 database. Those data are there. I'm not gonna log into that because I just hit that H2 console, to be honest with you. I tried it to use it with the IntelliJ based solution, but it's really problematic, and the only thing that worked for me was via file. But data is there. I'm gonna stop them right now, and we're gonna just go in main wave of monitoring. So one of those easy things that we can do with monitoring in Spring Boot application especially is to provide, I'm gonna go to POM actually, it's to provide definition so maybe dependency to actuator. What actuator does is give us some endpoint, which called actuator, and some base information. By default, the only endpoint which is accessible right now in current versions of, on recent versions of Spring Boot are, let's say it health. Exactly. Health is the only one accessible. The same configuration is for another service. But as you can see, we have some to-dos here in code. I'm gonna just put it for you guys to make it a little bit easier if someone would want to follow my steps after the presentation, for example. And I put all different stages of our presentation, one stage 1 till 4, to be able to follow all these different steps that we're gonna take right now. And yeah, to reproduce it by yourself, to learn it in your own time if it's needed. So as I said, the health endpoint is there. I'm gonna start it once again. I just forget about to show it to you. We have some request file. This one is for actuator. And yeah, let's try it. We see with actuator health whether the application is up and running. So the first one is smart mobility is up and running. The second one is up and running. So those are like really basic information, right? Yeah, let's stop them because we're gonna integrate micrometer right now. So micrometer is some kind of, it's not wrapper for Prometheus, but what it does, it's like for in JVM world, it gives us some very rich metrics that we can use for our Prometheus diagram. I'm gonna show it to you right now. So first, what we're gonna need, we're gonna add. It's gonna be very quick. We're gonna add the dependencies here. This is the micrometer dependency for registry Prometheus. As you can see, we have micrometer version, and I don't have it in properties, right? Okay, that's really nice. It comes with Spring, right? We have in Spring POM actually in the BOM, so to say, and we have Spring as our parent project. So all the versions gonna be here as part of all the compatible version, and we don't have to think about it anymore. We have parent structure, and I built my project in such a way that all the dependencies are saved in dependencies management of the parent, and the specific dependency can be used without a version in application on. So yeah, I don't need it right now. The version is not important, and let's do it the same for payment. And yeah, we have already we have a micrometer with us. We're gonna refresh the project. What we have to do right now, because when we started, we want to scrap it quite similarly to what we have for actuator health, but micrometer has for us some additional endpoint, which is called Prometheus. I'm gonna copy and paste it for 2 applications. But our application is up and running, but this endpoint is not found, right? What we have to do is add it into application YAML as additional endpoint for our actuator, so to say, which is available for us, right? That's what I said earlier. We're gonna go to another one. Copy pasting. Well, so yeah, we're gonna start it once again. Just briefly. That's very quick. Both of them actually. we're gonna go back to our activity request file. Let's say if it changes. So yeah, great. We can see some metrics right now. Plenty different metrics. So for example, CPU usage, JVM memory usage, some kind of high carry, CP connections to database, plenty different metrics. We can be overwhelmed with the number of metrics we received actually. But what is nice, it took us 1 minute maybe to get all those metrics, and those are like not problematic for performance of our application. We don't have to think about it actually. So it's really nice. We received it quite nicely and without any problem. So that's about it. Yeah, that's the first step that we took. Now we're gonna concentrate on Prometheus itself. So I'm gonna go to Docker. I hope Docker. So Docker is currently like one of those main technologies on the backend. Everybody has to know it. That's why I decided to put it here as well. We have some Prometheus image. We have also Grafana. We're gonna start it all at once, but the configuration step comes a little bit later, just after it actually. Then we have some information about applications. So those applications that we started here directly via IntelliJ, we're gonna pack into container, and we're gonna start it via Docker Compose. And we have a payment as well. So actually, we can distinguish 4 different, so to say, containers, right? What we can do, I have some bookmarks. The bookmarks is not a magical thing. You can add some bookmarks. I'm not sure if anybody using a big fan of it. Specific folders to bookmarks, and you can have it accessible right here. I've made some simple scripts just to make sure everything is up and running. And for example, I have some setup all, which is gonna some kind of like cleans all containers. It's gonna build my projects and start those containers again. So yeah, let's use it. I hope it's working. But we didn't change. We didn't make any configuration changes, right? But we're gonna see if it's up and running. Okay, in between, we're gonna go into Prometheus YAML. Prometheus YAML is, so to say, help component. Oh, great. I have always the same problem. I didn't stop the existing applications. But that's fine. We're gonna explore it a little bit further, and we're gonna start it again, because we're gonna make some changes into Prometheus itself. So that's the Prometheus YAML. It's like kern of the Prometheus configuration. Everything happens via this file. What we have here is some global information about scrape internal. So how often do we want to scrape all our targets? And target stands for all different application and the endpoints that gonna provide metrics for our monitoring. So those settings that we can see here in global is gonna be added, or gonna be quite, let's say, take into consideration for every definition. What is funny, and that's why what Prometheus recommends, to scrape Prometheus itself. So we have Prometheus up and running on this port. We're gonna make sure if it's the same, right? And Prometheus is gonna scrape itself. So Prometheus give us that API, and we're gonna monitoring it as well via Prometheus. That's quite interesting. But let's dive into our application. First, I'm gonna show you some basic concept. How can we add some new target? So firstly, we're gonna add some smart mobility, and the metric path that we're gonna explore is, as we saw it previously, it's called actuator Prometheus. And then we have some kind of static configuration. And here comes the first step. We give some static configuration, which means we're not gonna observe it from, let's to say, DNS or from file. And this option is not it's not so flexible, so to say. But I'm gonna show it to you right now. What we are gonna to do, we cannot provide localhost, right? Why? Because we are running the Prometheus is gonna be is gonna be run in so to say Docker network. So that's why we're gonna access all different components. But of course, the localhost from Prometheus is a Prometheus because it runs in itself, so to say, application. But all the other components are accessible via the name of that service, right? So when I want to scrape the smart API, I'm gonna provide that's via let's to say Docker domain name. What we can do here, so what we've done here is we've added some first endpoint, right? Okay, let's try it. Let's use it our script to start all different containers. Let's see whether it's running. I don't have any running application, so that's good. That's good. Okay, so I have some basic basic links here, a little bit area, but it's not important. We have Prometheus on our local host. And how can we say whether the specific target has been added properly? We can see it here, and we see it's down, but I think it's gonna be okay. Just we're gonna need some time to start it. Okay, let's see it. Maybe we have some kind of problem. Let's see. Whether the application is up and running. Okay, it seems fine. Let's try it again. Okay, I think I know where my problem can be. Yeah, exactly, because that port of this application is different, right? It's not with one. Let's try this one more time, and yeah, I'm gonna kill all the containers, and I'm gonna show it to you, or maybe not. What we can do, as I said, those are like static configs, right? We can kill all the containers. We can start the Prometheus once again, because what it needs to be done now is to reload the Prometheus configuration. We can do it via already existing endpoint. So when I go to my scripts, I don't see any script with that, but I'm gonna add it just very quickly. And let's say it's gonna be Prometheus HTTP and reload. Let's reload Prometheus config file. Okay, that's the command that we're gonna use. That we're gonna post it. We have 200, and let's say if it's any better. I'm gonna refresh it a little bit, but yeah, it's much better now. We see that a specific endpoint is being scrapped, right? What we can also see under service discovery under the smart mobility, all different labels, right? By default, every label has information about instance and job. That comes by default, but we can add so another information as well. Okay. Good. That's the first step. As I mentioned, this step is not that, I would say, it's not that flexible. And what we can do, instead of defining those metrics via static config, we can define them to via DNS, but that's not what we're gonna do today, but via, for example, file. We're gonna put our metrics, our, so to say, systems metrics under smart city. We're gonna say the path name is metric path is the same, so it's gonna be actuator and it's gonna be Prometheus. Okay, and we're gonna say that we're gonna use some file SD configs, and we're gonna say that files that we are using are, let's say, targets JSON. Okay, we don't have that file yet, but what is cool, when we're gonna add it, all the changes in that file is gonna be automatically picked by Prometheus, and we don't have to, like, so to say, start it or maybe reload it again. So let's add some file which is gonna be target JSON, and I'm gonna just make it like as it is right now, right? And now we're gonna refresh it because we need to tell the Prometheus, okay, I have added some new file, but what is in the file, it's now it's gonna be like automatically picked. So let's go to Prometheus. Let's refresh it once again. Check. We have 200. And we can see what we see is like, okay, we have nothing. Okay, that's good, right? Because we don't have any definitions in our target. We're gonna provide them, as I said, via JSON. And the first one is called target. And as I mentioned, the first one was smart mobility on this port. Let's not do this mistake again. And what is cool, we can put some additional labels to that. Let's do like language that was used in that specific. Sorry, that's not an array. We're gonna use the smart mobility. Sorry, smart mobility is written in Java. Okay, let's do the Java. Let's say framework is, so to say, Spring Boot. Okay, and let's say that application is called smart mobility. Okay, we've added the first target. When I refresh it, it should be automatically picked. Okay, but it's not. Interesting. But I'm gonna reload the configuration, so maybe, yeah, that's help. But it should be picked for sure. I did everything right, I hope. Sorry, Prometheus YAML. Okay. Instead of targets, put target. Those tips. Okay. Let's do it once again, just to explore it a little bit. So once again. And yeah, we're gonna go to that Prometheus HTTP. We're gonna post it. Okay, great. Now it's gonna be, I think it's good. It's targets, and we're gonna add it as it is, as it was. And let's try it again. Okay, let's do it. I'm gonna just refresh it, but let's add another target here, which is gonna be called payment, right? And payment works on another port. It's written in Kotlin instead of Java, and the application name it's okay. I'm gonna check really quick. Okay, those are not here with us. But I think application, I think so far we put it correctly. I'm gonna refresh it. Okay, interesting. I think I might have some problems. Those presentations problems. Sometimes that's what it is. I'm gonna kill containers and set up once again. Okay. I know where my problem might be. Another mistake. So instead of targets. Okay, great. Let's running again. Great. Let's see whether Prometheus. Okay, it looks promising. It looks promising. So yeah, as I mentioned, the problem was with target. That's why automatically it wasn't picked. And now let's wait a little bit. Yeah, I think those applications are not there yet. Let's see. Supposed to be healthy. Okay, the first one is already there. The second one as well. Great. We go to service discovery, and we can see that under the smart city, we have application. We see more labels because we added application, we added framework, and let's say language. Great. How can we use them? So let's explore all the metrics that comes with the micrometer. So for example, we have some logback events total. So on which level has been specific, let's say log information was logged, and we see how does it look. We see the labels for the metric for specific whole dimensional, which is say area, and that's why we have to be sure that whatever we add is really helpful, because we're gonna just add more complexity for that specific metric. But we have information about payment, we have some information about smart mobility, and what we can do here is we can use that selector logic to say, okay, we want to just see on the level which is called, so to say, info, right? And we see that we have 15 messages on that specific endpoint. When we go to our business HTTP requests, and we're gonna add something new, and if we get 200 as a response, yeah, great. We should see some more information about them, right? Exactly. So we see that on the smart mobility application, we have some more logic, and more logs, and on the payment application as well, right? That's the first type of how we can see something. Then we have another metric which is called counter, as I mentioned, and we have some information about HTTP, how long the specific request took to be finished, and we see some specific endpoints. We see also the URI for Prometheus, but I can say also, let's say that I want the the URI for only for my reservations, right? Or for my payments. And yeah, that's how it works. What we can do here also is to say, okay, let's play with time here a little bit. So I can say I'm gonna get all the metrics in the last 5 minutes, right? And you can see it's not that helpful. It's helpful, but we can see it's not that clear to read. But we can say we can use some rate function just to group them together, and we see now rate says how in that specific 5 window period how many requests per second. So how many each request took was working on for per second, so to say. Yeah. And what we can have here, we can say also sum for that specific, let's just say, result, and we have some sum metric. So all the seconds in the last 5 minutes window for all our requests, right? So it's helpful. We can also say what was our CPU usage for specific application, and we can see it in graph, for example, right? And it's peaks sometimes and peaks sometimes, and that's the graph. But as we can see, it's not that helpful. Actually, we get some information, of course, but actually those are not that, so to say, clear for us, right? We want be able to have it in some one place. That's when the Grafana shines the most. What we can do, and what we can do in the first place, we're gonna add some source. We have many different sources, right? And that shows how powerful Grafana actually is. But today we're gonna concentrate on mythology. Let's start with Prometheus. And let's say we're gonna scrape Prometheus. We have the same situation as Serial. We're gonna connect it via domain name from Docker. And let's say if it's working, data source updated. It seems fine. And now let's go to the dashboards, and then when the magic is, let's say we're gonna generate very rich dashboard under 10 seconds or maybe 20. That's the magic website, which calls the Grafana Labs, and we have dashboards. Let's say you want to show something from Spring Boot. We have plenty of them. Let's do the Spring Boot 2.1. Okay, we have 2.7, but 2.7.5 actually, but I think it should be good. We're gonna copy ID, and we're gonna put it directly here. Okay? Let's load it. Great. Let's say smart city JVM monitor, and we're gonna take Prometheus as a data source. Okay. Okay, we have another problem, I think. I'm gonna just I'm gonna explore it a little bit. Okay, I took the wrong one. Okay, let's delete this one because I had 2 data sources. Maybe that was some kind of old configuration. Let's go to the dashboard and let's see it once again. Okay, I'm not gonna use it anymore. I'm gonna just update it, just take it once again, and it's the same new ID. Okay, those 20 seconds were more, but it's worth it. Smart city, another JVM monitor, let's to say. And now we're gonna have, I think, yeah, great. we have rich dashboard right now, right? We see what is the uptime. We see some heap usage, non-heap usage. We have CPU usage. We have JVM, heap and garbage collectors information. We have threads. We have disk buffers as well. Here we have garbage collector information. We have connection to database. How many are there? What is cool? We use Tomcat, not Jetty, but this diagram by default uses Jetty. And what we do have also is some logback information. Great, right? It's what we get here is like astounding how much information we get quite free. We have here information about payment. We have smart mobility. All those are those 2 targets that we configured. We can also have multiple instances of specific application, but we have single instance in our solution, so to say. Yeah. What we can do right now is to load test a little bit. I have Postman with me. Postman has quite good possibility to load testing. It's quite easy, but it gets job done quite nicely. When we go on the specific collection, we can say run collection, and we can say let's run it 10 times, for example. Okay, I'm gonna start it, and we should see some metrics here. The specific logs maybe has been recorded, and so on. Let's see. Let's wait for a second. Yeah. Okay. We don't see anything yet. Okay. Some of those were client side problematic, so we have some client errors, but others were quite good. Oh, great. We have see some info on the sorry. Here, info logs. We see some payments endpoints. Great. We can see some request durations. Great. That seems we see some database operations. We see some HTTP codes. Great, right? It's working. It's working quite nicely. What I want to share with you is the last step. What we did so far was some kind of JVM monitoring, right? I hope it's working. Great. Let's add a new row, and let's say that's the last topic I'm gonna cover today. Let's say business metrics, so on. Okay. What we want to achieve right now is to be able to push some our defined metric. Okay, let's dive into code right now. And what we want to do, we want to go, our business case would be that I want to add some information about confirmed reservation as well as canceled reservation to be able to track them down, right? How to do it? First, we go to reservation service, go to the adapter of it, and we're gonna provide some new basic information. The first one is called counter. We're gonna import it from micrometer project, and we say confirmed reservations total. Okay. Then we're gonna add another counter, which is gonna be called not confirmed, but maybe canceled. Okay. How we configure them? We're gonna use metric meter registry from micrometer as well. We're not gonna use it as a field of the class, but we're gonna use it to define our metrics, right? So I can say, let's use builder, and I'm gonna use it to say that's the name of our business metric. It's gonna be called confirmed reservations total. Total suggests that comes from naming. It goes from naming convention of Prometheus to say, okay, counters are good to say count or total. It's good. We have some problem here, but it's solved. And what we can do is also, let's say, we can add description. So it's a total number of confirmed reservations, right? Right. Copy pasting. We're gonna define quite similarly the other one, and it's gonna be cancel the reservation. We're gonna change the metric name to canceled. Canceled. And it's going to be total number of canceled reservations. Okay, great. Those are, let's use this convention in constructor. Okay, those are not yet used. Let's go to our business code. Let's go to confirm method. And that's the simple business logic of confirmation. And let's say, okay, before login, we're gonna say confirm reservations total. We're gonna increment it. Yeah, as I said earlier, counters could be only incremented or maybe resetted, but not downgraded. And then we have some cancel logic as well. We're gonna say increment our cancel logic. Okay, great. We added that. What we need to do is go to reservation config, and we see some exceptions here because we want to meta registry, but it comes as a bin, so we can inject it here. Okay, great. So last but not least, let's go once again to our service. Let's see where that metric is there. Actually, we have some empty result. Then I'm gonna open my magic script. So I'm gonna reload Smart City. What it do? It just reloads not the whole containers, but only those business ones. That's why the whole process is gonna take not that long. I'm gonna provide all those metrics, those information, maybe in some kind of a rich and nice way, right? Okay, let's see whether it's working. We don't see it yet. Let's see whether our targets are working properly. Okay, not yet. Let's wait. Let's wait for the second one. Great. We should see that new metric. Okay, so we don't see it yet because we didn't use it. But when we go to let's go here, right? We see something. That's great. We see number is 0. Okay, let's load test it a little bit. We're gonna add some metrics, some data into it. We're gonna provide the Prometheus some basic data. It scraps every those 15 seconds. That's why we don't see it every second, but now we see it already, right? That's the first one. That's not confirmed. Maybe we have some more in a little bit. Yeah, we have 3, but we also have some canceled as well, right? Great. It shows here it's knows about it, we're gonna execute it as well. We have two. Great. We have those two metrics. Last step, we're gonna add some panel which is gonna show us reservation status, or maybe something like that, right? And what I want to do is on those confirmed ones, right? And I'm gonna add some legend to it, and I'm gonna say, let's say, confirmed. And on the other hand, I'm gonna say business. It's quite nice that he knows about them already, so we see it right away. And we're gonna name it cancelled, right? We're gonna save it, we're gonna apply it, and we see we're gonna move it a little bit just to our business metric. Maybe we want to move it a little bit down here. And yeah, we see some business information as well. Let's load test it a little bit, and maybe we're gonna see some metrics more, right? That's the goal of it. Yeah, let's wait. Okay, I forgot about it, about something, I think. Yeah, there's automatic refresh. Let's see, let's wait for more seconds. Great. So we see it's like automatically updates our business metric, our custom metrics as well. So that's about it in terms of our technical part. I'm gonna switch right back into to our presentation, and yeah, I hope you liked that coding time. It took a little bit longer as expected, but I think we did quite a nice job there. So yeah, let's sum it up, right? What we learned today. We learned that monitoring is, and what monitoring is, and what are different types of it. We also know why we should know it, why we should use it, and how can we convince our clients or our colleagues to use it as well. We know that APM stands for Application Performance Monitoring and serves as the most complex monitoring type of the model. That's why we decided to dive into it. And via Prometheus, we just noticed that it exists not only in Mythology, but as a really cool and really rich open source tool for scrapping metrics of our systems and applications. We took a look at Smart City and we monitored it without much effort. All right, with some problems, but we were able to do it. And yeah, Grafana serves beautiful dashboards for our sometimes maybe not particular pretty metrics, right? Some information maybe we don't want to know, but are there, right? And it's shown right quite nicely. And yeah, I think the last meme here is self-explanatory. What we did today. What next? What's the next steps that we can take to make those APM stack even richer than that currently is? We just made the first step, right? It's the first basic step. We concentrated mostly on the application level monitoring, but we can use it. We should and we could and should monitor our containers on production as well. We can also monitor our platform, Kubernetes, AWS, Azure, or cloud providers could and should be monitored as well. Then we know, so Prometheus also offers native clients libraries. We use those via micrometer, so to say, for Java, but currently there in market, there's like for almost every programming language, there is a native library, official and not official, which is very cool. We have Alert Manager, which we didn't touch at all. It's based from based complex alerting system based on different logic and different rules that we can apply. We can push the notification on our cell phones, mails, Slacks, and Teams, and so on. We also can have exporters which gonna like provide metrics of not applications but maybe like system, like operating systems as well. And the Grafana itself also tools to enhance the telemetry. Loki collects application logs, and Tempo serves distributed tracing, and we can all tools can be put in Grafana via browser, via single application, and we can use and scribe all those metrics to have even better and richer insight of the application. So it's time for a brief Q&A. I'm gonna start it via our platform. The first question is, can I use Prometheus in Android development instead of Google Firebase? Actually not. So it's not supported directly because those, I didn't see any official tool for that, but I feel it should be possible via those exporters that I mentioned, or maybe via push gateways. So if it's not supported natively, I'm quite sure there's like possibility to do it manually. But for Android development, the Firebase is here up to date. Maybe there is some good integration between Firebase itself with Grafana. I think that's quite possible, but I didn't check it. Another question comes from Damian. How long does it take to implement monitoring in a production application? That's a really good question because we can what we did today was some part of production ready monitoring, right? Those dashboards could serve us as a monitoring. I think it's a very broad question, and it depends on numbers of steps that we're gonna define. I would say something from 1 hour just to have those dashboards, for example, even to a couple of months to be able to get custom dashboards, to be able to make those alert monitorings, to be able to scrub metrics from the OS, and just to make it a little bit richer, not a little bit, maybe it's a process that's gonna take some time. And I think there is like what is really important here, that's to convince the client that a specific step is really very important. And I think that's the main disadvantage, right? We have to be in contact with a client. We have to consult those solutions and be sure that it's worth it, right? From our perspective, from developer's perspective, every metric is worth it quite a bit. We can understand a little bit better, much better, what's going on our production environment, how many users there are, what's our limit of our system that we're building, how much memory do we need to increase in the near future. And those metrics are quite good for business as well, right? We can convince, I think business can understand metrics and numbers much better, or some kind of JVM information about heap size, for example. But when you say, okay, we're gonna run out of memory in the next 2 weeks, if we're gonna accelerate in the same time, that's some cool information. So that's really difficult to answer, Damian, once again. But as I said, from 1 hour or maybe 5 minutes, without any problems, to even a couple of months. Can endpoints for Prometheus, which are accessible via Spring Boot application, be secured via JW token or JWT or basic authentication? Of course they could. And what can be done here, and I can that Prometheus YAM definition can be put that authentication type, right? Can be base authentication, can be also some kind of secret in terms of Kubernetes. We don't have to provide the passwords on usernames directly. We can do it via secrets. So those possibilities are there. Yeah. So yeah, that was about Q&A session. As I said, thank you so much for VMPL and the best for possibility of this webinar. That was quite a pure pleasure for me. And I'd like to share with you some recent and actual job offers that we have in our company. The first one is senior DevOps engineer. The second one is React.js developer. So if someone would take into consideration and maybe join us, please write us and reach another vacancies on the VMPL/career website. But yeah, and that's about it. Thank you so much. I think with those small problems, we managed the end. Thank you so much for VM for having me, for supporting me here. Thank you, Kasia, for marketing, for making this whole thing possible. And yeah, thank you, Best Hacks as well. And thank you guys for coming here today, joining me today, and exploring this world of monitoring a little bit further. And yeah, it's not that mythological as expected. It's quite easy and it's quite handy as well. So yeah, thank you so much. And yeah, stay safe and build good monitoring systems, right? Bye-bye.